In this video, I'm going to solve this differential equation. By looking at it, it looks like an exact differential equation. So p of x comma y dx plus q of x comma y dy is equal to 0. P of xy is equal to 2xy, and q of x comma y is x squared plus y squared. To ensure that this is in essence an exact differential equation, we have to make sure that del p over del y is actually equal to del q over del x. So let's quickly check whether these two conditions satisfy. So del p over del y is equal to del y 2xy, right? So 2xy derivative of this is with respect to y is going to be just 2x. Similarly, del q over del x is equal to del over del x of x square plus y square. That is also equal to 2x because derivative of y square with respect to x is 0. So this is in essence an exact differential equation. If it is an exact differential equation, we know that there exists a function which sometimes is called potential function that is equal to c f of x comma y. How do we go about finding that? We know that p of xy, okay, p of x comma y is nothing but the partial derivative of f with respect to x. All right. Now, what is p of xy? This is actually 2xy, okay, and that is equal to del f del x. Now, if I go ahead and integrate both sides, so I'm gonna get integral del f del x dx, okay, is equal to f of x comma y, which is just gonna be integral of 2xy dx. All right, so f of x comma y is equal to 2y times x squared over 2 plus some function, let's call it g of y. This g of y is kind of serving as a constant, even though it's actually a function. Any function of y with respect to x integration would be treated as a constant. Now, if I simplify it a little further, f of x comma y is going to be x squared y plus g of y. Now, in theory, we found a function that is going to be solution to this differential equation. So how do we go about finding g of y? That's not too hard, really. You know that del f over del y is equal to q of x comma y, right, which is x squared plus y squared. So we are going to take the derivative of this function with respect to y, del f over del y, which is going to be just x squared plus g prime of y. But this must be the q of xy, that is x squared plus y squared. So x squared plus y squared. Now if you subtract x squared from both sides, then you are going to get g prime of y is equal to y squared. Now if you integrate both sides with respect to y, integral g prime of y dy, which is going to be integral of y squared dy, right? And that this integral is nothing but g of y. So g of y is equal to integral of y squared with respect to y is y cubed over 3. Now we take this value and plug it in right here. If we do so, we get f of x comma y is equal to x squared y plus y cubed over 3. So now this is the function that we have been looking for, which is going to be the solution to this differential equation. And this is, of course, is equal to some constant c. So that is the solution to this differential equation. I hope that this discussion was helpful. Thank you very much.